morning, good afternoon, good evening, ladies and gentlemen. Welcome to another exciting edition of the One Planet City Challenge, an initiative that transforms local action into global climate leadership. My name is Tabaré Arroyo Curras. I am member of the WF's One Planet Cities team, and today I have the pleasure of hosting you in this second OPCC webinar. A webinar that will investigate the scientific basis of climate change, its impacts and risks, and some of the options to deal with it. Besides, in this webinar, we will review some of the arguments that explain why cities are fundamental agents of change and how they can pave the way towards a climate-safe future for everyone. In summary, today we will overview key concepts and findings that envelop the status quo of the climate science for cities. This webinar has been prepared as a masterclass, and we hope that this serves well to provide specialized knowledge in an immersive experience that is useful to you and to your participation in the One Planet City Challenge in the OPCC. But before we start, let me go over a few simple housekeeping rules. At first, and in case I have not done so already, please make sure your microphone is muted. This will allow us to run a smooth masterclass with no background noise. Second, please make sure you submit your questions via chat box so we can go over them and answer them at the end of the webinar. Finally, let me say that for quality purposes, this webinar is being recorded. We will circulate the video podcast at a later stage. So, no masterclass can start without a master. And today our master is Dr. Christopher Weber, the Global Climate and Energy Lead Scientist at WWF. Chris came to WWF from 2° Investing Initiative, where he held lead analysis and methodology development on climate-related risks and opportunities in investment portfolios. Before that, he served as Senior Research Associate at the World Resource Institute, WRI, as a consultant to the UNEP Finance Initiative, and consulted on corporate sustainability for several Fortune 500 companies. Chris has served as research professor at Carnegie Mellon University, as a research staff member at the Science and Technology Policy Institute in Washington, D.C., where he's based, and where he has advised the White House Office of Science and Technology Policy on climate, energy, environmental, and innovation policy issues. Chris holds a Master's in Science in Civil and Environmental Engineering and a PhD in Civil and Environmental Engineering and Public Policy from Carnegie Mellon University. Chris, it is our pleasure to have you in this webinar, and on behalf of the One Planet Cities team, let me extend our gratitude for accepting this invitation. So, without further delay, I think it's the time to start the masterclass. Let's start the masterclass with Chris Weber. Dr. Weber, thanks for being here. Now, the floor is yours.
There we go. Hi, good morning, good afternoon, good evening, everyone. I'm coming to you today from Washington, D.C. in the States. I'm happy to be here and present to you some, as Tabaré said, about some of the key points about climate science and the role of cities in helping to solve climate change. So the title of this talk is called, as Tabaré said, Climate Science for Cities, Solutions to 1.5C. And we're showing here a picture taken outside the IPCC conference where the special report on 1.5C was settled by the IPCC in Incheon, South Korea, about 6 to 7 months ago. Several of us from WWF were here at the conference because this was seen at the time, and I think it's proven to be one of the most important reports in climate science to ever have been written. It really served as a kind of global wake-up call around the importance of climate change and the critical importance of hitting the Paris Agreement's agreed well below 2 and really striving for that 1.5 degree global target. So we're going to just spend about 30 minutes diving into some of the key messages of the report. But before we do, I think it's always a good idea to preview what everyone's going to say. So, or here in the webinar, we've boiled down. This is a massive report, as all IPCC reports are, and I've tried to boil it down here to the 4 key points that I hope you'll take away from this webinar today, and some of 4 of the highest level, most important points from the report itself. The first one is that every half a degree matters. We learned very clearly from the report that hitting the temperature limit of 1.5 C is much safer than going to 2 degrees C for both people and for natural systems nature. However, the current pledges by countries under the Paris Agreement, what are called the Nationally Determined Contributions, or NDCs, unfortunately are not sufficient. They're going to take us to over 3 degrees C as they currently stand, which would just be a disaster for people and nature. We know we can hit the 1.5 degree target. It's we're going to talk a little bit later in the presentation about this idea of feasibility and how feasible it is for the world to hit this target. And the report's very clear that that it is far from impossible for us to hit this target. This was one of the key questions going into this report, and one of the things that the IPCC was most centrally asked by the UN to look is it still feasible for us to hit the 1.5 C target? And the good news is it is. The slightly less good news is that the report is also equally clear that it would require unprecedented transitions across all aspects of society. And we'll talk about what those look like and what the role of cities is in those transitions. And finally, one of the maybe less promoted key findings of the report, but one of the most interesting elements is that limiting warming to 1.5 degrees C can go hand in hand with achieving many of the other global goals that the world has set itself out for, including the Sustainable Development Goals. So we're going to go now into a little bit more detail on those 4 key points. The first, I'm going to break this talk up into 3 key parts. The first is about kind of setting a level basis, making sure that everyone understands the ideas of climate change itself, and what we've seen to date in terms of climate change. Then we're going to turn and look forward in time and say, what do we know, and what does the report tell us about what we can expect to see in future climate change, and what does that mean for potential impacts and associated risks associated with climate change. Then we're going to dig deep on the role of cities, because obviously this is the One Planet City Challenge webinar series, so you're all here to hear about cities and the role that they can play in helping us hit that critical 1.5 degree target. And then we'll take some questions at the end. So first, we want to make sure that we're all coming with an understanding of kind of the basics of climate change. It's really critical to set the basics first, because the understanding kind of the relationship between greenhouse gas emissions and climate change is the first core piece of understanding what to do about it. So greenhouse gases affect climate change through an aptly named effect called the greenhouse gas effect. Many of you have probably seen Al Gore's wonderful movie, An Inconvenient Truth, that spends a good amount of time explaining all of this. But just so we all remember kind of what the basics here are, most of the energy and life on Earth originally comes from the sun. Sun beams us with all of this energy. Some of it is reflected back to space immediately, but a good chunk of it actually comes in and warms the surface of the Earth, maintains plant growth, all the good things that support life on Earth. At the same time, part of that energy is re-radiated. It's absorbed by the Earth and then shot back into space through infrared radiation. And we have this interesting effect where basically greenhouse gases, things like carbon dioxide, methane, water vapor, so all of the water that is in the atmosphere, actually trap some of that radiation that's going back, serving as, I think, Al Gore called it a blanket around the world, basically. And this blanket, which is made up of these gases, basically traps the radiation and warms the inner atmosphere of the planet. Now, obviously, because that warming is driven by those greenhouse gases, if we were to, say, start emitting more greenhouse gases, we would eventually increase that effect and drive the global temperature up. And that's exactly what we've seen happen over the past several hundred years, but really accelerate over the past few decades. So this is one of the key graphics from the report that shows that one of the key things to know is that globally speaking, we've seen about 1 degree of warming in 2017, which is the last date that the data that the report was looking at. Obviously, if you look at this graphic, it's showing multiple things. The gray line goes up and down. There's a lot of variability. That's we know that the climate is not a simple thing. Obviously, there are certain years that are hotter than others. Some of it's cyclical, some of it is just pure chance. But you can see in the red line is the long-term trend, and the long-term trend is very, very clearly moving up, and we've seen this 1 degree of warming. Now we know that's driven, as we explained in the previous graphic, by greenhouse gases. So the lines line up very clearly that the acceleration in warming that we've seen since the kind of 1980s are very clearly aligned with the acceleration of the emissions, in particular of CO2, which has started going up much more since the 1980s, 1990s. And what does that do? As we emit more, what's being shown in the middle of the screen here, more of the CO2 stays up in the atmosphere, because CO2 actually has a very long life in the atmosphere. It stays there for hundreds of years. So as we emit more and more of it stays in that blanket around the planet. And CO2, of course, is not the only gas as well. And we're also seeing emissions in the bottom right of all of these what are called non-CO2 gases. And as both of these go up, we see a more effective blanket, and that drives the global temperature up along this orange profile. One of the key things to note, though, is that while we call this global warming, and you'll hear people like me use global temperature to describe climate change. So we have not all the people around the world and not all the natural systems around the world feel this global warming or climate change the same. Part of this is just driven by where people live and where natural systems occur, but part of it is also driven by the climate itself. So we have this 1 degree of warming that we've seen globally speaking. But actually, if you look around the world, different people have seen more or less than 1 degree. And actually, a relatively sizable chunk of people have seen already more than 1.5 degree of warming, which is that the key limit that is highlighted in the report. The graphic here is showing this. If you look at the darker reds, there are places in the world that have already seen 1.5 or even above 2 degrees warming. Many of the folks on the line probably come from cities that are in some of these globally hotter locations, just based on the time zones of where we are. And key thing to know, of course, is that a lot of those hotter areas happen to align with where people live. So we're seeing more and more the climate change affecting people in the places they live, and it's getting hotter and hotter with time. Now, the temperature, of course, is only one indicator of climate change. We also are already seeing substantial impacts on ecosystems and on human systems. This is one of the key graphics that summarize some of these impacts, with the blue icons showing impacts to physical systems, things like melting ice and permafrost, effects on water systems such as floods or droughts, and coastal impacts such as erosion or sea level rise. Green impacts showing those to biological systems such as wildfire and direct impacts to ecosystems, and the red showing impacts to human systems such as food production or human health or economies. Key thing to note here is that different regions have different mixes of impacts, and this makes it somewhat challenging to speak like global truths about climate change, because every region is different, and some regions are seeing impacts that compound with one another. In particular, you can see the polar regions, which is shown in this box. Basically, everything is changing very quickly, and we're seeing the impacts accrue to both the physical systems, the biological systems, and the human systems. So what can we say about what we've seen to date? The key message here is that every year of warming really matters, and we're already seeing this 1 degree of global warming, which has translated to more than 1.5 or even 2 degrees of warming in some places, and we're already seeing these relatively severe impacts occurring because of the climate change to natural systems, to human systems, and to our climate and weather. Now I want to change tacks. So we've talked about what we've seen to date. Now we want to look forward in time and say, okay, well, what does this mean for the future? Because climate change, as you're probably all aware, is a kind of multi-decadal process. It unfolds over long periods of time, and we're going to take a look now at how these things might unfold over the next few decades. Going back to this idea of greenhouse gas emissions, one of the key findings of the report is that the amount of global warming that we can expect over the coming decades is obviously quite tightly related to the choices that we make now and the emissions that we're going to see in the future. So this graphic takes that temperature rise that we've seen to date and starts to look at how things might unfold in the future. The first thing to note is that if we keep going on the trajectory we're going, which is this dotted line, we're going to hit that 1.5 degree limit around 2040, 2050. This sort of, I'm really bad with colors, and this graphic's tough for me because of that. But what this graphic shows is a sort of climate response if we were to kind of follow what the report highlights as one of the key pathways to limit warming to 1.5, which is that we try to hit net zero emissions, where we're no longer emitting greenhouse gases, or any residual emissions that we are balanced by emissions that are being sucked up by trees and natural systems by about mid-century. And the key things to note is that how fast or how slow we decarbonize the economy is going to have direct impacts on how the likelihood that we are of hitting this target. So the difference between these two areas is if we go faster on CO2 emissions, we're going to have a better chance of staying below that 1.5 line. And like the same way, if we go slower on CO2 emissions or slower on the non-CO2 emissions, which is what's being shown here, we're going to have a less good chance of hitting that temperature target. And you can see what this looks like by kind of digging into the report, looking at some of these different pathways where the gray, the gray box can turn into the green box if we cut emissions faster, like it's shown on the left side. But if we cut emissions slower, as it's shown on the right side, we're going to have, again, that lower chance of hitting the temperature target that we're interested in hitting. Now, this is all very theoretical up till now, but the reason that we care is because of the future impacts of climate. As I talked about before, we've already seen these relatively severe impacts of climate change around the world, but we know that the impacts are going to get worse as the climate changes. So one of the tricky things about communicating climate change is that the impacts are so different in different places and so different to different types of systems. So the IPCC has worked on trying to figure out how to communicate this for some time. Eventually, and since the last few reports they've done, they've used these kind of high level, what are called reasons for concern, or RFCs, and shown these, what has now become known as the burning embers diagram, which shows the risk levels kind of going from white or undetectable up to like a purple, which is a very high level of risk across these various reasons for concern. Things like unique and threatened systems, things like the coral reefs, for instance, that are likely to be the first harbingers of impacts, extreme weather that everyone's probably very familiar with, the distribution and the aggregate of these impacts, and some of the really big, large-scale changes that could significantly affect a large number of people around the globe. An example here would be like the ocean conveyor belt that heats Northern Europe, if that were to slow or shut down. The first thing to note here is this graphic shows at 2 degrees the line, and at 1.5 degrees a horizontal line. You can very clearly see that for almost all of the reasons for concern, there's a significant increase in risk if we go from 1.5 up to 2 degrees. That is obviously very important, because the Paris Agreement highlighted both of these goals, the 2 degree and the 1.5 degree. And one of the key things that the IPCC was asked is basically how much worse is it if we do 2 degrees versus if we do 1.5 degrees. And the very clear finding here that 2 degrees would be substantially worse. But the other interesting point is that actually another key message of the report is that it's even worse than we thought. What we've been kind of saying here is there's this other key message that 1.5 is the new 2. And here I've taken this reasons for concern graphic and basically plotted in the dotted lines where the previously thought levels of risk for 2 degrees were. So science obviously progresses with time, and as we learn more about climate change, we're able to assess with different levels of certainty how much risk there is at different temperatures. And the dotted lines represent where we thought 2 degrees was. And you can see across the board in the new report, where we thought 2 degrees was is mostly aligned with where we now think 1.5 degrees is. Hence this phrase, 1.5 is the new 2. Whatever risk that we thought we were hitting at 2 degrees when the Paris Agreement was written, we actually need to we need to go to 1.5, because otherwise the risk increase is going to be far too severe. Another way of looking at these risks is to try to kind of show examples of the different risks to humans. So one of the things we did was kind of dig into the report and pull out some of these key differences between 1.5 and 2, and put it into a kind of a nice infographic that would allow people to really kind of dig into the differences between the 1.5 and 2. So here we're kind of going back and forth. So you can look at one of the places in the graphic and sort of see what some of the key differences would be. And I'll just highlight a few of them. WWF obviously cares a lot about natural systems. On land, the impacts of biodiversity and ecosystems, including species loss and extinction, are projected to be much lower at 1.5 degrees compared to 2 degrees. We're going to have much lower impacts on species and ecosystems in terrestrial or land-based, freshwater and coastal and ocean and marine ecosystems, and crucially to be able to maintain more of those ecosystem services that we all depend on. Looking at kind of the more human side of things, climate risks to health, livelihoods, food security, water supply, human security and conflict, and economic growth are all projected to increase substantially with global warming of 1.5 degrees, but then increase further if we go to 2 degrees. One of the key questions then is sort of, well, can we adapt? And there's large parts of the report that look at these questions about adaptation. We know the report tells us that adaptation needs are going to be much lower for global warming of 1.5 compared to 2. There's a wide range of adaptation options that we can use to help reduce the risks of climate change. However, there are limits to how much we can adapt. And once we get beyond 1.5 degrees, a lot of those limits start to be hit in certain places and in certain systems. So we go from what's kind of technically known as a risk to what's technically known as a loss. We just can no longer adapt, and the risk becomes something that's just lost potentially forever in the case of things like species extinction. So second key message coming out when we're talking about looking into the future, every bit of warming matters. Half a degree might not sound like that much. It's certainly, on a daily basis, our weather goes up and down by far more than half a degree. But the key thing that we know from all of the immense amount of science that's gone into this report and to the IPCC in general is that half a degree really does matter. The difference between 1.5 and 2 is actually really substantial in terms of impacts and risks. And to be able to reach that 1.5 degree goal, what we need to do is ensure rapid and deep cuts to greenhouse gas emissions, those CO2 and non-CO2 gases that we were just looking at. And at the same time, we're going to also have to remove carbon dioxide that we've already emitted from the atmosphere, including through things like what are called nature-based solutions. The use of mangroves in coastal systems, forests, soils, and so on. So we're going to find the final part of the talk here. We're going to go into a specific look at cities and what cities can do about climate change. Obviously, cities are why we're all here, why we're all together across time zones around the world. And the report itself, as well as a very nice kind of follow-on report that was done called the Summary for Urban Policymakers. If you know IPCC, you'll know that the kind of key document that most people look for is called the Summary for Policymakers. This is the high-level kind of summary of the overall report, because these reports are hundreds of pages long. A key group of city stakeholders put together kind of a city-specific version of this called the Summary for Urban Policymakers. And that looks at some of these specific dimensions for cities in terms of the impacts and risks of climate change on the one hand, and the role of cities in driving down emissions on the other hand. So we're going to dig into a little bit of this. So on the one, again, if you look at these kind of two sides of climate change, the one side being impacts and risks and the other side being solutions, cities are super crucial in both. Cities are really at the front line of risks on where we'll start. Obviously, we all know the broad statistics. Cities already host more than half of the global population, and it's likely to be around 2/3 of the global population in 2050. 80% of the global economy runs through cities, and they represent 65% of global energy use and 70% of global CO2 emissions. Cities are a big deal for the global economy. Partly because of this, and because they are the centers of population and economic growth, they are also exposed to risk. Though, in particular, megacities, along with some kind of cities on small and low-lying places like islands and coastal regions, are going to be highly affected. They are already seeing substantial urban growth, with 70 million new urban residents arriving per year until the mid-century. And the majority of those are moving to these kind of hazard-prone small and medium-sized cities in low and middle-income countries, where we're seeing the kind of combination of a high level of potential exposure to climate change, which we showed on you remember that map graphic, that looking at the distribution of temperatures, and also because of partly because of them being low and middle income countries, they also have potentially a lower capacity for dealing with climate change. So this kind of one-two combination makes risk exposure particularly bad in these places. At the same time, we know that a lot of the impacts of climate are going to specifically hit cities. So coastal cities are going to be very affected by sea level rise. Urban heat island is a very big deal already in many places, and it's going to get even worse. And all of these risks kind of across the board are affecting urban stakeholders already, and all of them are likely to get worse in the future, including water scarcity, air pollution, flooding, disease vectors, fire risk, etc. So that's the bad news. Luckily, there's some good news too, which is that cities at the same time are right on the front line of solving climate change. We're just going to highlight what the report has a lot to say about the transitions that we need. This was one of the key things that the IPCC was asked. What do the transitions that we need to avoid getting above 1.5 look like? One of the key transitions they highlight is called the urban transition, and it has a lot of different elements. just going to highlight 5 of them here. The first is urban expansion. That the anticipated growth in population is going to require extensive new construction of urban infrastructure and buildings. On average, as we've said, the urban land cover is already expanding at twice the rate of urban population growth. So we need really deliberate policy interventions to curb this sprawling land use, which is problematic for several reasons, because it's connected to often poor transportation planning, and also because sprawl is eating up usually natural systems that were there before, many of which store carbon, and so are releasing carbon as they are converted over to urban space. Second is direct energy consumption by buildings. Buildings, we know, already represent 1/3 of global energy consumption, but they also possess considerable energy saving potential. Nowhere in the world has harnessed the energy efficiency that is really needed. And one of the key aspects of the report that the report highlights is the role of kind of demand side actions, such as energy efficiency and sustainable consumption, in driving down emissions. Under 1.5-degree pathways, for instance, we know that electricity supply by renewables is going to need to reach like somewhere between 70 and 85% of total electricity. And so buildings have a really important role to play of kind of integrating renewables themselves, such as through solar, wind, solar and batteries integrated into buildings, and also linking smart energy systems to the broader renewable revolution. Now, the third is the green infrastructure. As I already said, as urban areas grow, they're utilizing resources and services from these surrounding ecosystems, which leads to a decrease in ecosystem services for the urban area. And a loss of some of these functions that we need, such as flood control and the regulation of drought that some of the green systems can provide. All of those decreases can exacerbate what are already happening in the local climate and weather extremes. So if cities can work to improve green infrastructure within their urban boundaries, this can help control the flooding and droughting that are expected to get worse with climate change. They can enable water conservation, and very crucially, they can help reduce the urban heat island effect, which is really a substantial problem. And it's pretty incredible just how important urban tree canopy, or having trees in cities, can be to help prevent some of the worst urban heat island effects that are going to get substantially worse as extreme heat continues to get worse and worse. So fourth, I think no surprise, is transportation. In the transport sector, we need, the report highlights that we need to see low carbon fuels making up, including electricity and hydrogen, making up over half of transportation energy by 2050. Cities can help solve this problem by smart urban planning that decreases the need for carbon-intensive transportation in the first place, such as compact, pedestrianized cities and towns. The planning should be coupled with policies that encourage improved fuel economy, zero-emission vehicles, such as electric charging infrastructure, and very importantly, modal shifts towards walking, cycling, public transport, and shorter commute distances. Not telling anybody anything they don't know, I know. Finally, cities are important for enabling the kind of lifestyle choices and changes that we know are going to be necessary in the future. Perhaps for the first time in this report, the IPCC really focused on these sort of actual changes that people need to make in their daily life. Things like changing to walking and cycling for their mobility, things like reducing their energy demand, reducing their demand of materials and sustainable consumption patterns, shifting their diets. This was somewhat controversial, to be honest, but it's become very clear. The science is astonishingly clear on this point, that it's much easier for the world to hit these the temperature targets that we're looking for if we can enable sustainable lifestyles in people, rather than just focusing on the production side of the equation and trying to change our energy systems, change our transportation systems without changing lifestyles. Now, one of the final points that I want to make is that how feasible is this? And we were at the press release for the report right after it was finished. Everybody was super tired and super interesting, and over again, every reporter just kept asking the same question, like, well, right, but is it feasible? Can we do it? And this is the thing that everybody always wants to know, because the report is very clear that very aggressive changes are needed if we're going to get there. The report, it doesn't take a simple stance on this idea of feasibility. There's no yes or no answer. Instead, what they sort of say is that there's a need for kind of looking at a multidimensional approach to feasibility, and that there's a lot of different kinds of enabling conditions, things that are listed here, things like geophysical, ecological, technological, social, cultural, institutional changes that and institutions that are built, many in cities, that help to increase the feasibility of making this transition. Things in making the transition for mitigation include things like we've already discussed, solar and wind associated with batteries, bioenergy, energy efficiency, electric vehicles, better public transportation, low energy buildings, reduced food waste, and ecosystems and green infrastructure. At the same time, multidimensional feasibility for adaptation includes things like conservation agriculture, green infrastructure, again, where we get both a double dip in wins for mitigation and adaptation, appropriate building codes and standards that incorporate resilience into them. One of the interesting things, finally, in the report is this question of sort of how does climate change fit in with global development? Where can we find kind of synergies with these big transitions that we know are needed to meet the needs of climate change while also meeting the needs of development? I don't have a lot of time to go into this, but it's a very interesting message, basically, that what the report says is that there are many more synergies than trade-offs between the climate and the development agenda. In particular, we see the pathways that lead to a 1.5 degree world having a lot of synergy with 4 of the SDGs highlighted here. The health one, affordable and energy access, sustainable cities, obviously, and sustainable consumption and production. At the same time, there are some trade-offs. Depending on how we go about these mitigation pathways, there could be trade-offs with poverty, hunger, and clean water and sanitation. So finally, I just want to talk about some of the enablers of the urban transition that are discussed in the report. Effective governance frameworks are obviously very key, as they are across many parts of society. We need to have effective local responses that engage the community, including minority communities, in participatory decision making. Obviously, we need technology. We need accelerated innovation, deployment of the technologies we already know about, and good upkeep and operations and maintenance. We need renewable energy. We need energy efficiency, and the increasing use of clean fuels and non-motorized transit systems are going to be one of the key things that enable cities to make this transition. And finally, again, kind of new in this report, the IPCC talks a bit more about kind of the social dimensions, the influence strategies, community approaches, tailored information and feedback provision that are, enable these sustainable lifestyles that the report rightfully points out are needed to make the transition. So the final point is, final key point to bring home then is, just like every degree matters, every year matters, every action matters for cities, for urban policymakers, for people working in the urban environment. And I will close just with a quote that I think kind of captures a lot of this, which is from Deputy Secretary Jan Eliasson. Cities are where the battle for sustainable development will be won or lost if we fail. So thank you for your time and listening, and I'm happy to take a few questions now.
Thank you very much, Chris. Fantastic. I think we have gone over an extraordinary presentation, one that has helped us learning and understanding better the basis of the science of this and how this is impacting us. I think we have a couple of questions in the chat box. Maybe we can go over some of them. We have a few minutes for this, let's say 10 minutes. And let me start with one question that is focusing on the Paris Agreement. The question, I will just read it from the chat box, my dear Chris. Is it accurate to say that Paris includes a 2C goal? Article 1 refers to well below 2C and pursuing efforts for 1.5, but not 2C alone. So basically, I think the question is asking what difference between 2C, well below 2C, and 1.5?
Yeah, it's a great question. So as this question rightfully points out, that the Paris Agreement doesn't make a specific reference to 2 degrees C. It Article 2.1a calls out the global goal of well below 2C with efforts towards 1.5 C. The problem is they didn't define what well below means. This was partly a political choice because it's a term that kind of allows different people to take away different messages. And there was also a split at the time between many of the kind of low-lying islands and developing countries that were really pushing for 1.5, and some of the developed countries that wanted the target to be around 2. So they ended up at this language of well below 2 with efforts towards 1.5. There is no specific mention of 2, thus, but there is a lot of uncertainty as to what well below 2 actually means. To some people, they take away from that basically a 50% chance of 2 degrees, and other people take away a 90% chance of 2 degrees as meaning well below 2. It's really in the eye of the beholder, which is partly why the UN asked the IPCC in this report, let's take the 2 extremes, just take 2 degrees and 1.5, and tell us what is the difference, both in terms of impacts and risks, and in terms of kind of mitigation pathways of going on the one hand for 2 and on the other hand for 1.5. And that difference will hopefully help us figure out what we want to shoot for and what well below 2 really means.
Thanks, Chris. So, dear participants, you are welcome to submit more questions to the chat box. In the meantime, I will raise another one, and this is a personal one, Chris. There's always this conversation about the 1.5 and the 2 degrees and above, and I think you have explained very clearly the scientific arguments why we should pursue more ambitious target setting. But historically, why we started talking about 2 degrees Celsius and then we moved to 1.5? Is a 1.5 a real target? There is something political driven in the Paris Agreement. So maybe you can give us a little bit more of context of why now we should be flagship in 1.5.
Yeah, sure. Thanks, Tavare. So it kind of goes back to the Paris Agreement, but obviously it goes back considerably further before that as well. Originally, the first point is that 2 or 1.5, neither of these are magic numbers. It's not like there's like after we hit 2, everything falls off a cliff, or after we hit 1.5, everything falls off a cliff. It's all there's variable levels of risk, and the levels of risk obviously are different for different types of systems. What the emerging climate science in the era of the kind of late 2000s going into the Copenhagen COP was pointing to kind of 2 degrees as, for all intents and purposes, a sort of safe threshold that we could shoot for, that also that kind of balanced the practical mitigation concerns of the countries of sort of how quickly do we need to decarbonize, with and obviously there are moral dimensions to this question, so I don't want to use words like acceptable risk, but like some of the UN parties sort of felt like that was maybe an acceptable level of risk. There's no like specific reason why it has to be 2, and in fact there's a lot of literature discussing sort of why was this taken, like why did we center around 2 to begin with, when we know now that like the risks of going above 1.5 are really bad, and partly it was just we didn't know enough, I think, and partly it's that 2 is a nice round number. There's a lot of dimensions to sort of why we settled on that in Copenhagen and then in Paris.
Thanks, Chris. Chris, we have a final question. I think for the sake of time, we need to start wrapping up. But I really would like to read 2 things. The first one is a congratulations from our participants to your extraordinary and excellent presentation. So thanks for that, Chris, and thanks for you participants to be here in this webinar. But we have a very interesting question, and this question relates again to target setting. It says, how does a city set targets for reduction of greenhouse gases emission? Is there any methodology to be used?
A question after my own heart. I spent a lot of time thinking about setting targets for companies and cities and everything. So absolutely, yes, there are a lot of good tools and methods out there for setting reduction targets. I will note that the OPCC is one of the leading providers of such tools and methods. There's actually there's a lot of work going on right now to try and kind of define what an appropriate GHG reduction target for a city in line with the Paris Agreement or in line with this 1.5 goal should look like. And I can go into more detail, but I think in the interest of time, I will just say that either stay tuned or follow up with your OPCC colleagues in WWF, because they'll be able to point you to a lot of really great tools that you can use to set such a target. Perfect.
Thanks, Chris. Thank you very much for answering to these questions. Thanks again for the presentation. Just for audience, and I hope I am sharing my screen now. If there's any remaining question, unfortunately, we would like to cover many more that we just received. But if there's any other question, feel free to contact us or to contact Dr. Christopher Weber at chrisweber.wwf.org. So once again, Chris, thanks for this presentation. We hope you enjoyed this webinar as much as I did, and hopefully as much as our participants enjoyed as well. So there's one thing that I would like to say. We are in the moment to start closing this webinar, and you say 3 key messages. Those messages were every year matters, every degree matters, and every action matters. But now I would like to challenge you a bit, Chris, and adding one more key message, and that one more key message is that every choice matters. Why I'm saying this? Because I think this is a good opportunity for people to make the choice to join WF One Planet Cities Challenge and inspire the world. And if you are interested in doing this, there are a couple of things that we will invite you to do. And first is to confirm your interest either to your local WWF office or through the core team of the One Planet City Challenge, which is in Sweden, is based in Sweden at OPCC at WWF.se. This report, this initiative fosters transparency and as such invites cities to, through the CDP and ECLAIR reporting platform, to submit data about the efforts they're doing in terms of climate change. So if you're interested in participating in the OPCC, we invite you to opt in the OPCC through the CDP reporting platform whenever you are submitting your information. I will also like to encourage people to meet the data reporting requirements. More information there in the websites that are portrayed in screen. And finally, to make sure that you're submitting your information before the deadline, which is July 10. Now, an emerging question would be, why should a city do this? Well, there are many reasons that I think Dr. Christopher Weber have explained, but a couple of extra is that when you join the OPCC, there are three main added benefits that you will get. One is that we precisely go over methodologies and will help you setting the targets aligned to the Paris Agreement, particularly to the 1.5C. So you know that you're in line with the maximum expectation of safe planet vision. We also guide you with big win impact measures and strategies that will help you increasing your potential of climate action. And as well, we create conditions to help you get some public recognition on your climate efforts in a way that you also inspire other cities in your country all around the world in terms of how far we can get into climate change. So I will finally say one more thing. As probably you know, the One Planet City Challenge is a biannual initiative. We started running the 2019-2020 cycle, which brings another benefit to you, and this is an in-depth capacity building through webinar creations. And at the moment, this is our second webinar, and I would like to extend the invitation for you to participate in our third webinar taking place on May the 7th at 8 o'clock Eastern time of the US, in which we will address more in detail what are these step-by-step approach to scope, plan, and submit your data as city in order to participate in the One Planet City Challenge. The One Planet City Challenge is a global initiative that it is not run only by WWF, but by WWF with the great support of fantastic organizations such as the Carbon Disclosure Project, CDP, as well as ECLAIR, the local government for sustainability. So as Chris said, if you're interested, please tune in on May 7th on the next webinar and learn how you can improve your data submission to the platforms. In any case, if you have any questions about what's OPCC, how you can participate, what other value it has, what benefits you can get, I invite you to also review our previous webinar, which is, you can find the link in our website at www.panda.org/OPCC. But alternatively, you can always contact us. We will be happy to answer to your questions and to come back to you with valuable information that assists you in developing more ambitious climate actions at your city level. Final words, I think there are many chances, many opportunities to interact with us. I invite you, as I said, to review our website. There's fantastic information there. You can see who has been participating in OPCC, who has been the winner, what is our We Love Cities campaign, what events for public recognitions we have done, etc., etc. Very good source of information. But also I invite everyone to follow the OPCC, the One Planet City Challenge, in our social media. So either on LinkedIn or Twitter at WWF Cities. So I think with this, I we are running 1 minute out of time, so I need to close now the session, not without saying thank you to all for participating in this. Again, good morning, good afternoon, good evening. Thanks for joining this second OPCC. Dr. Christopher Weber, I promise you a big round of applause, so I do it on behalf of the group. So my name is Tabaré Arroyo Curras. I had the pleasure of hosting this webinar. Hope to see you in the next one. So now the webinar is over. You may all go in peace. This session has finished. Thank you very much.